Welcome to my YouTube channel. Myself Shreyas V from Sri Venkateshwara College. I am studying at third sem Computer Science and Engineering, and today's topic is Stack and its operation and application. Let me introduce you to the topic. A stack is a data structure that follows last in first out principle. In a stack, the last element added is the first one to be removed. Think of it like a stack of plates. You add a new plate to the top and remove the topmost plate when needed. Similarly, in a programming context, elements are added or removed from the same end, often referred as top of the stack. This structure is fundamental for various applications in computer science, such as managing function calls, expression evaluations, and undo mechanisms. Next topic is stack operations. There are four types of stack operation. The first type is push operation. This function removes the top element from the stack. If checks, it checks for a stack underflow when the stack is empty. It decreases the top of the stack to point to the next element. Here is an example for this operation. Void push int stack. Next operation is pop operation. This function removes the top element from the stack. It checks for the stack underflow when the stack is empty. Decreases the top of the stack to the point to the next element. This is an example for pop operation. A syntax used is void pop. Next operation is display operations. This function displays all elements of the stack. It checks if the stack is empty and then prints each element. Here is an example for this operation. A syntax used in this is void display. Next operation is overflow and underflow. Overflow occurs when trying to push an element onto a full stack. Underflow happens when trying to pop from an empty stack. This example initializes a stack pushes element, displays the stack, pops element, and displays again. It demonstrates the handing overflow and underflow conditions. Here is an example where we use push operation and pop operation both to display or a delete an item. Next are applications of stack. There are five applications in stack. The first one is function call management. Stack are crucially a managing function calls in programming language. When a function is called, its local variables and and the point of execution are pushed onto the stack. Upon completion, the function's context is popped from the stack, allowing the program to return to the calling functions. Here's a syntax for this application. Void function. Next application is undo mechanism in software. Stacks are used to implement the undo features in software application. Each action that modifies the state of program is pushed onto the stack. When a user requests an undo, the last action is popped from the stack, effectively reversing the operation. In this operation, we use void perform action and void undo action. It is void perform action is used to push an element and void undo action is used to pop. Next application is expression evaluation. Stacks are employed in evaluating expression. especially in compilers during the parsing and evaluation of mathematical expressions. Stacks help in managing operands and operators, the post-week evaluation of expressions in a classic example of stack usage. In this syntax, we use int evaluate expression. Next application is backtracking algorithms. Backtracking algorithms such as n-queens problems or maze solving often utilizes stacks. Stack keeps track of the choices made at each step of the algorithms. If a dead end is encountered, the algorithms backtracks by popping choices from the stack. Here we use syntax which we use in this are void solve problems. Next application is memory management. Stacks play a role in managing memory and programs in low level programming. The call stack is used to allocate or deallocate memory for local variables and function calls. This helps and ensures efficient memory usage. Syntax used in this are void allocate memory. It is used to allocate the memory. Void deallocate is used to deallocate the memory. Means allocate means we are creating a memory. Deallocate means we are deleting a memory. Let me conclude this topic. Stacks with their last in first out structures form a foundational data structure in computer science. We explored key operations like push, pop, display, emphasizing their significance in managing functions calls. Implementing undo mechanism, evaluating expressions, aiding backtracking algorithms, and facilitating memory management, the versatility of stacks extends across diverse applications. From software development to algorithms, problem solving, mastery of stack operation is essential for design design efficient algorithms and creating resilient software systems. As you continue your programming journey, delve into delve into further exploration to unlock the full potential of stacks in solving real world computational challenges. Thank you guys. Let me conclude this presentation here.